So here's from the Stats Medic, which is based out of Grand Rapids. They're from East Kentwood High School. They do a lot of great work. I just wanted to, before, I know Hikmet, you wanted to go over some multiple choice questions, and we can definitely do that from the 2012 multiple choice test that we've been working on. I just wanted to give you an idea of two different types of predictions that these people who make great curriculum have. So first off, this is what they predict. Now, they have absolutely no inside information about these, but they have been graders. So this is what they think the 6 questions are going to be. So a one variable data question. So describe, compare distributions. That's your SOCs and context, probably categorical data, maybe a 1 proportion Z interval test in some variety. And then if we go horizontally across, maybe a 2 variable data question. So describe the relationship. So that's strength, outliers, direction, and shape. That's our SODs. They call it DUFs, but whatever, plus context. Make a prediction or calculate the residual. Always it's the data minus the predicted value. That gives you your error measure. Interpret slope or R squared, sounds about right. And then how does an outlier affect the y-intercept or the slope or the correlation coefficient? So yeah, I think outlier or point of leverage. I think those would go hand in hand. Third question, probably a sampling experiment type question. Observational study or experiment. Is it statistically significant? The scope of the inference, which means like how much can we generalize this? We went over a couple of those. And then maybe confounding or blocking. So confounding is like, what are the other types of variables that we couldn't separate out? Or blocking, how does blocking allow us to isolate a variable? So those are 3. Question 4, most likely probability question, maybe a normal distribution calculation, an and probability, a binomial calculation, or like using one of those 3 to calculate a p-value. Question 5, probably a significance test. Their guess is a 2 sample t-test for the difference of means. So what do you need to do for that? Define a parameter, check the 10% if sampling without replacement, which means if they're not independent. Part B, probably a error analysis. So is it a type 1 or a type 2 error? What would be the impact if those errors occurred? And then lastly, investigative tasks. So probably build off like a hypothesis, condition fail, use a simulation to estimate the p-value and compare the simulated p-value to a calculated value. And this again gives you a rough estimate of what they are thinking. And you can see how they did last year. I think their 2019 prediction was the most accurate. If you wanted to actually look back at what they predicted versus what actually was on the test, you can see it kind of runs similar. So 1 variable data, 2 variable data, sampling and experiments, a probability question, a significance test, and then the investigative task. So you can see if when you've done enough of these tests, especially for the free response questions, that there's certain beats that we need to cover to show that you understand the main ideas from this course. So over the past 8 months, do you see the connections between these? So I just wanted to give this to you guys, kind of highlight the points of, in almost every single problem that we went over this week, it's imperative that you put in the context of the situation. The difference between most math classes and a statistics class is that you as the human need to tell me what is going on with these numbers, not just what the numbers are. In most cases, you can't just jump straight into the calculation, but you have to go over the conditions. So if you want to remember panic for confidence intervals, or what we had phantoms for a hypothesis test, both help in just remembering what are the things that you need to do in order to have a complete answer. If you're giving you a simulation, of course, with a simulation, you want to somehow devise an idea of randomness or blocking or We've talked about different ways of doing that, cluster samples. Always be aware of correlation versus causation statements. Just because two things have an association does not mean that one necessarily causes the other, especially in observational studies. We do not want to use that causation vocabulary. If, on the other hand, it is an experiment and you can control for outside variables, especially with randomness, experiments allow you to make more causal statements. And that's why we do experiments. So we can say this causes the other thing for this context. And that's why usually in most research papers, they will say there's more study that needs to be done in order to truly understand this phenomenon. We know how to interpret p-values. Always think you're comparing the p-value against an alpha level of what's the level of significance that needs to show you that something unusual is going on. Because our null hypothesis is like nothing to see here. There's nothing unusual in this situation. And lastly, there's a difference between a random sample versus random assignment that we've gone over. So with that, I'll kind of end this preamble and go questions, or how do you want to go about this last day of review? Hikmet.
Just some multiple choice practice ones.
Okay. I can do that. Oh, there it is. Wonderful. Do you remember the question that we left off on?
31. Well, I think we did up to 30.
Okay. Let's just go through the last couple of them. And honestly, when I gave you guys this as a sample test, it's helpful to put yourself in the situation of the AP test. Take one of these, put a timer on yourself, really assess your ability on how you do this. So with 31, large number of randomized experiments were conducted to determine whether taking a particular drug regularly would decrease the chance of getting a certain disease. For each of the experiments, the drug effect is the difference between the proportion of people taking the drug who got the disease and the proportion of people taking a placebo who got the disease. Okay, so we have that set up. If the drug had no effect whatsoever, which of the following experimental results would be anticipated? If the drug had no effect. Okay, so one says p-values will be greater than 0.05 for about 95% of experiments. I would say that's true. 2, there will be about an equal number of experiments showing positive and negative values of drug effects. That is also true because that's saying it's a 50-50, which is saying that when we do this multiple times, the p-value is greater than 0.05. So 1 and 2 are kind of saying the same thing. 3, when 95% confidence intervals for the population of drug effect are constructed, those confidence intervals include 0 about 95% of the time, which is true. If we know that there's no effect whatsoever, the difference, because we're comparing two things, shows no change, which is what we're testing. So for this, if I read this question correctly, the only answer for this is E. (32). As a part of a class project at a large university, Amber selected a random sample of 12 students in the major field of study. All students in the sample were asked to report the number of hours spent studying for the final exam and their score on the final exam. A regression analysis on the data produced the following partial computer printout. Okay, so this is a linear regression analysis. Amber wants to compute a 95% confidence interval for the slope of the least squares regression line, the population for all students, assuming the conditions for inference as satisfied. Which of the following gives the margin of error for the confidence interval? Okay, so margin of error, if we're doing slope, plus or minus our critical value of n minus 2 times s over the square root of n.
I want to just briefly fix this, so I know I'm inserting this into the video, but if we are finding, for this question, Amber wants a 95% confidence interval for the slope of the least square regression line. So if we're building a 95% confidence interval, we are going to be taking the slope, so I'm going to say B1 plus or minus our critical t-value, and for linear regression it's n minus 2, and then we want the standard error of the slope. So when we are looking for the critical value, this is just 12 minus 2. And so we can either use inverse t, and we want a 95% confidence interval, so we do 0.975, comma 10 for our degrees of freedom, or we could look at the choices on the distribution below. The second part, which is what I made a mistake on the first time, is that when you write out the standard error bit, you should be able to find the standard error of the slope from our computer printout. Now, when you see this, the only option for this, noting that all of these have 2.228 as our critical value, it's really asking you for, can you identify the standard error for a linear regression model? And so it's not B, like I originally said, it is A. 2.228 times 0.745.
33. A mathematics competition uses the following scoring procedures to discourage students from guessing. On the multiple choice questions, for each correct response, the score is 7. For each question left unanswered, the score is 2. For each incorrect response, the score is 0. If there are 5 choices for each question, what is the minimum number of choices that a student must eliminate before it is advantageous to guess among the rest? So this is an expected value question, which would also mean that so what you're dealing with is the expected value of guessing, right? I'm asking how many choices would you have to eliminate out of the 4 options before you would guess? Now, clearly, if it's asking for the minimum number of choices, obviously the minimum number is like, if you eliminated all 4 options, there are 5 choices. So if you eliminated all like 4 of the wrong ones, of course you're going to get 100% right. But that doesn't mean it's not advantageous. Like if there was 3, if you were able to eliminate 3, that means the choice is a 50-50 guess. So if you eliminate 3, it's a 50% chance you get it right. And the score, so the expected value of getting it right would be 7 plus 0, right? You would either get it right 50% of the time, or you get 0 50% of the time. So your expected score, if you were able to eliminate 3, would be, well, I can do that, 3.35. Eliminate 3. If you eliminate 2, so let's say we're going with 2. If I eliminate 2, that means there's 3 choices. That means it's a 1/3 chance. So if I have the probability of getting it right would be, I mean, there's points that I would get is 7 times 1/3 plus 0 times 2/3. Well, this should still be a positive number. So the expected number of points you would get for strictly guessing eliminating 2 would be 7 times 1/3, which is 4/3. Would be 7/3, 6, 2. So that's 2 1/3. That's your expected number of points from guessing. So we're trying to find the minimum number of choices that students must eliminate before it's advantageous to guess among the rest. Well, if I only eliminate one, then there's a 4 out of 5 chance, or a 20% that I get it wrong. And so my expected value is going to be a lot less. That's like 7/5, which is 1.2 if I eliminate one. I would only expect to get 1.2 points for each question correctly. So then this is saying, if there are 5 choices, what is the minimum number of choices? I would say 2.3.
I also want to clarify number 33, and it's because in our explanation, I neglected this fact. So for each correct response, the score is 7. For each question left unanswered, the score is 2. For each incorrect response, the score is 0. So if I leave the question blank, I would get 2 points. And so this is the number that I want to compare my scores to. Now, as we saw, if we eliminated all 4 choices, I mean, you could do, if you eliminated 0 choices, you'd be guessing. And so if there's 5 options, that's a 1 in 5 chance you get it right. So that'd be 7 times 1/5 plus, well, the other expected value you would get would be out of 4/5. So this is part A. I mean, that's A. That is 7/5. That is not greater than 2, so we would rather leave it blank. If you could eliminate 1 choice, then it's, you can see this is going to be 1 out of 4 that you'd be guessing, plus 0 out of 3/4, which would be 7/4, which is 1.75, which is still less than 2. So for C, if we go eliminate 2 choices, now it's a 1 out of 3 guess, plus 0 times 2 out of 3, which gives you 7/3, which is 2.3 repeated, if I do that right, which is greater than 2. So if it's asking what is the minimum number of choices the student must eliminate before it is advantageous to guess among the tests, the minimum number you would need to eliminate is 2.
34. The probability that a new microwave oven will stop working in less than 2 years is 0.05. Not working. Probability that a new microwave oven is damaged during delivery and stops working in less than 2 years. 0.04. The probability that a new microwave oven is damaged during delivery is 0.1. Given that a new microwave oven is damaged during delivery, what is the probability that it stops working in less than 2 years? Okay, so we have probability. So we have probability not working, probability damaged, and then we have the overlap. So this is 0.04. Probability that it's not working in less than 2 years is 0.05, so that's 0.01. And the probability that the new microwave is damaged during delivery, so this is 0.06. So it's saying, what is the probability that it stops working in less than 2 years? Wouldn't that be?
So again, as future Mr. Swenson interjects from the video, here, if we are looking for the probability that it is not working, given that it's damaged, then this is just saying what's the probability that it's not working and damaged over the probability that it's damaged, if that's the formula, or it's just saying what's the probability of being 0.04 divided by 0.1, which is 40%.
35. Percolate is a chemical used in a rocket fuel. People who live near a former rocket testing site are concerned that percolate is present in unsafe amounts in the drinking water. Drinking water is considered safe when the average level of percolate is 24.5 parts per billion or less. Random sample of 28 water sources in this area produces a mean percolate measurement of 25.3. Which of the following is the appropriate alternate hypothesis that addresses their concern? So our null is that I would say this is less than 25.3. So our alternate should be greater than 25.3, which means it's not, sorry. Drinking water is considered safe when the average level is 24.5. So I want our null to be less than 24.5. That means my alternate is mean is greater than 24.5. That one's a lot easier than the probability questions. 36. The computer output below shows the result of a linear regression analysis. Which of the following statements is the correct interpretation of the value 19.0? That's the slope. So I'm looking for which one identifies the slope. So A, on average, there is a predicted increase of 19.0 parts per million in concentration of lead for every increase of 1.1 part per million in concentration of zinc found in the fish. Maybe. On average, there is a predicted increase of 19.0 parts per million in concentration of zinc for every increase in 1 part per million concentration in lead. Okay, so this goes to what's the explanatory variable and what's the response variable. Slope is always change in y over change in x. So I want increase in zinc per lead. That gives me B. Let's just go over the predicted concentration of zinc is 9. No. The predicted concentration of lead is 19.0. No. They have approximately 19% of variability. That is not what R squared is. So though, no, no. So the only answer is B. 37. Hopefully you guys aren't tiring out for this. There were 5,317 previously owned homes sold in Western City in the year 2000. The distribution of sales prices of these homes were strongly right skewed. With a mean of 206,274 and a standard deviation of 37,881. All the possible random samples of size 100 are drawn from this population, and the mean is computed for each of these samples. Which of the following describes the sampling distribution of sample means? So first off, if I have a population of 100, then I am going to get closer and closer to the population mean, which is 206,274. My standard deviation is going to shrink as my sample size goes up. So it's going to be standard deviation over the square root of n, which is 37881 over, well, it's 100, so that's over 10. So that's pretty easy. So let's find the one that has our mean and our standard deviation and our sampling distribution will be approximately normal. I believe that says that's what A is. Approximately normal with the mean of 206,274, which notice it's the same for all of them. So really this question is going to, do you understand standard deviation? 38. A physician believes that the exercise habits of East Coast adults are different from the exercise habits of West Coast adults. To study this, she gathers information on number of hours exercised per week from a random sample of East Coast adults and a random sample of West Coast adults. Which of the following might be the appropriate null hypothesis for this study? If I'm comparing the two, the null hypothesis would be there is no difference in the minutes exercised. So I want to read each one of these looking for there is no difference, which is the null hypothesis. The average number of hours exercised per week for East Coast adults is different. No. The average number of hours of exercise per week for East Coast adult is the same as the average. The same would be the mean of the East Coast would be equal to the mean of the West Coast, which would also be the same thing as the difference is 0. So I'm just going to go right to it. The answer is B. I don't need to read the rest. Don't confuse yourself once you find the right answer. Last two, sir, that you asked for. For a roll of a fair die, each of the outcomes, 1, 2, 3, 4, 5, 6, is equally likely. A red die and a green die are rolled simultaneously, and the difference of outcomes, red minus green, is computed. This is repeated for a total number of 500 rolls. Which of the following graphs best represents the most reasonable distribution of the differences? If I do this experiment 500 times, knowing that each one is equally likely, first off, let's look at the axis. If it's equally likely, the most common result over 500 times should be 0. And this should look normal. So of these distributions, which is the one that looks most normal? The answer is C. And that's it for that one. 40. The probability of winning a certain game is 0.5. If at least 70% of the games in a series of n games are won, the player wins a prize. The possible choices for n are n equals 10, n equals 20, n equals 100. So 10 games, 20 games, or 100 games. Which value of n should the player choose in order to maximize the probability of winning a prize? Okay. This question is going to, if it's advantageous for the player, which one has the highest variability? The larger the number of games, the more, the less variability of 50, it'd be closer to 50-50. I want it to be closer to 70% of the games that I win a prize. So I want n to be the lowest amount. So if n is equal to 10, and I'm not going to do any of the calculations for this, but the lower the amount, the higher the variability. The higher the variability, which means the more chance I have of actually winning a prize. And so that takes us to the end of the multiple choice section. Are there any questions that you want further explanation on?
Wait, for 37, why did the standard deviation change again?
Oh, because we are looking at the sampling distribution.
Mm-hmm. Well, why doesn't the mean change?
Oh, the more, do you remember this is like the NFL salaries?
Yeah.
The larger and larger the sample we took, the closer the average of our sample matched our population mean. What did change, however, is no matter what the distribution was, in this case, a very skewed distribution, the sampling distribution, the standard deviation actually shrinks by a factor of the square root of n. And so that's why it becomes this normal model, is because while the mean stays the same, the standard deviation becomes more concentrated, which forces the curve to be approximately normal.
Okay.
Now I should be able to, yeah, you can also see here that for a sample mean, the standard deviation of the statistic is sigma over the square root of n. And that's what we're really looking for, the sample mean of the sampling distribution. Other ones?
On that one with the die, what did the axes mean? Like the negative values? 39.
39. Oh, what are we comparing? We have two different colored die that we're rolling. Let's say it's red minus green, right? So whatever the number on the red die says, minus the number on the green die. Make sense? So let's say you on the red die, you roll a 1, and the green die, you roll a 6. What's the difference?
Oh, like -5.
-5. So we record that. If I roll it again and the red die says 5 and the green die says 2, what's the difference?
-3.
Well, that one would be +3 because the order in which the two numbers show up matter. So I could have negative values. I could have positive values. Now, is it possible to get -6 or +6 as a difference?
No, because you can't get 0.
So in both of those cases, noting that you can get negative numbers, that limits your options to C or D. Everything else doesn't match this comparison.
And what does the y-axis mean?
How many times you would expect to get each of those?
Okay.
So if you're rolling it 500 times, which is what it says, what's the most likely outcome?
Like out of 1, 2, 3, 4, 5, 6.
Yeah,
In any of them, they're equally likely.
they're all equally likely, right? So if they're all equally likely for both die, the most common difference is going to be 0.
Yeah.
That's why. If they're all equally likely, then you're equally likely to get the same number on each, as opposed to a distinct difference, which is why when we do this more and more times, you're more likely to see a difference of 0 than you are to see a difference of 3. Why? Well, in order to get a difference of 3, that means you either have to have a 5 and a 2, right? A 6 and a 3, or a 4 and a 1. That's it. It's a small number for red and then green. It's a specialized case, right? So there's less of those. And you could also flip that in a mirror way, that there'd be less of getting the difference of a 3 or a 4 or a 5, right? They taper off because they're more specific. Like you're asking, how do I get the difference of 5? Well, the only way to do that is getting a 6 on the red and a 1 on the green. So how likely is that? Overall, we could calculate that, but it's not very high. Because it's 1 for the first one and 1 for the second one. So it's 1/36 over 500 as the expected number I would get. And I could do the same thing for each one of those. Any other of these multiple choice you want to go over?
I think that's it.
Okay. So I think we'll call it here in
Wait,
terms of.
real quick.
Yes,
For
sir.